everyone. Today in this video, we are going to talk about a very new topic and a new branch of mathematics, which is called as trigonometry. Before we start for that, let's understand the basics of trigonometry, or how did this concept of trigonometry was developed. Trigonometry basically deals with right angle triangles, and then later on these rules of trigonometry are applicable for obtuse angle triangles and acute angle triangles. But the basic rule is it's applicable for right angle triangle. Now few things of right angle triangle is fixed, and we know that it is standard. That means one of the angles is a 90 degree, and the side opposite to that 90 degree is called as the hypotenuse, which is also the longest side of the triangle. Now, so in right angle triangle, there are only two angles whose measurement are never known, because one of them is already fixed as 90. So there are five different uh, information of this right angle triangle that we'll be using to form the basis of trigonometry. Which are the five information? The three sides and the two angles, which are unknown. The measurements are supposed to be given. Now, basically the three side ratios are depending on the angle which is being taken care of. So suppose if I say here in triangle, as you can see, ABC is a right angle triangle, B being the 90 degree right. Okay. So if suppose I say angle A, for angle A, this angle A, which side will be lying next to it? That means which side is the adjacent side? Adjacent means which is just next to it. So if you see here, AB becomes the adjacent side, right? Whereas for the same angle A, BC becomes the opposite side, right? Now in the same triangle, as I shift the angle as C, the opposite becomes AB, because for angle C, the opposite side is AB. Opposite means which is just in front of it, just opposite, as it means in English. And the one which is just lying next to it means one of the arms which is forming this angle is BC, and that is adjacent. So what is the key point here is the moment you change the angle for the same triangle, the two things which shift is the adjacent side and the opposite side, right? Hypotenuse is going to be the same. So something with this particular concept, we are going to define basis of trigonometry. Before we go into it, let's have a look into the history of a little bit of a background of trigonometry. So trigonometry was originally created by Greeks to study astronomy. What are stars? How is star and moon related? How are the full moon, no moon, the phases of moon, how far the star is from a particular pole star? So they understood and they tried to study about astronomy based on trigonometry. And even today, the astronomy, various calculations are based on trigonometry. Next, earlier astronomers used to find the distance of the stars and planets from the earth. The word trigonometry has three parts. Tri means three, gon means sides, and metron means measure. So trigonometry means measure of what? The three sides. Measure of the three sides. The trigonometry is a branch of mathematics concerned with specific functions of the angles and their application to the calculation, which you are going to understand and apply the basics rules in this particular class. Okay, so let's talk about the basic rule of trigonometry. So ratios of the sides of the triangle. Which triangle? Right angle triangle. With respect to this acute angles is called as trigonometric ratios. So we'll be taking two side ratios. Those two sides ratio will be considered based on the acute angle that we are considering. Okay. So in total there are 6 trigonometric ratios, and these ratios express the relationship between the angle and the length of its sides. So let's start. I'm going to first take the angle A. Again, we are going to label opposite and adjacent side. So for angle A, the opposite side is, yes, BC. And adjacent side is AB. So in short form, we write it as capital H for hypotenuse, capital O for opposite, and capital A for adjacent side. Similarly, if you look for angle C, the adjacent is this, opposite is this, and hypotenuse is this, right? Or if you are confused, if there is a labeling of a side vertex point as A, then you can say ADJA for adjacent, and OPP for opposite, and HYPO for hypotenuse as a short form. Okay, so let's start with the first ratio. The first ratio is called as sine and the name of the angle. If there is no name of the angle, then normally we take a Greek alphabet called as theta. This is theta, theta, right? It's not O, it's theta. So sine theta, in this case, I'm taking it as A. So I'm labeling it as theta, right? So sine theta is always opposite upon hypotenuse. It's always opposite upon hypotenuse. So in this case, the opposite side is BC and the hypotenuse is AC. Similarly, for this triangle, sine, let me say C because I'm taking C. Again, the same rule, opposite upon hypotenuse. But the side which is opposite to this side, angle C is AB upon, yes, AC. That's the first trigonometric ratio, right? The second trigonometric ratio, which is very important, is cos. There's 6 trigonometric ratio. It's sine and cos, which is very important. The remaining 4 we obtain by taking relationship between sine and cos. How? I'm going to explain one by one. So the next trigonometric ratio is cos theta. And the cos theta is adjacent upon hypotenuse. So in this case, the adjacent is AB upon BC. You can just see that, right? The next on the side, cos C. Cos C, again, cos is adjacent upon hypotenuse, which is BC upon AC. So what is the basic rule? Sin theta is opposite upon hypotenuse and cos theta is adjacent upon hypotenuse. That is the key formula or the key ratio that you need to remember. The ratio sides will change according to the acute angle that you are taking. So the next third ratio which we are going to talk about is tan theta. And tan theta is always sin theta upon cos theta. Right? So if you take this ratio of sin theta, it's BC upon AC. Right? That will be equal to AB upon BC. So if you see the denominators are same, sorry, made a mistake. Sorry, that was AB upon AC. Sorry. So this AC and AC goes cancelled off and you get BC upon AB. Same way here, tan C will be equal to what? Sin C upon cos C. The denominators are same. So directly you can say the numerator of sin C, which is AB, divided by the numerator of cos C, that is BC. Right? Now, the next 3 ratios are just the reciprocal of these 3. What do I mean by that is cosec A or cosec theta is 1 upon sin theta, reciprocal of sin theta, which is AC upon BC. Sec theta is reciprocal of cos, which is 1 upon cos theta. In this case, it is AC upon AB. Okay. And the last one is cot theta, which is 1 upon tan theta, which is AB upon BC. So let me quickly revise this. Okay. Sin theta is opposite upon hypotenuse. Cos theta is adjacent upon hypotenuse. Tan theta, sin theta upon cos theta, or we can say it as, let me write down the rule again. Okay, and then we again understand. So this is the basis. If we are taking this theta, opposite is the side, adjacent and hypotenuse. So sine theta is opposite upon hypotenuse. Cos theta is adjacent upon hypotenuse. Tan theta is sine upon cos, yes, but if you talk about these sides, then it is opposite upon adjacent. Tan theta is opposite upon adjacent. Cosec theta is hypotenuse upon opposite, just the inverse reciprocal of sine. So hypotenuse upon opposite. Because sec theta is just the opposite of cos. Sec theta is just the opposite of cos, which is hypotenuse upon adjacent, and cot theta is just the reciprocal of tan. So it's adjacent upon opposite. Let's take two examples to understand this and solve it. Now here in this triangle ABC, they are saying it is right angled at A. So this is A. Then you can put your B and C wherever you want to put the acute angles are B and C. It can be B here and C here, but A should be 90. Now read the question. AB is 12, AC is 5, and BC is 13. Right? Now they are saying find all the trigonometric ratios for the angle B. So this is my theta or B. So for this B, it's hypotenuse. This side is adjacent and this one is your hypotenuse. Sorry, opposite. Again, for B angle, AB is adjacent, AC is opposite and BC is hypotenuse. So let's talk about sine theta. Sine theta is opposite upon hypotenuse. Opposite is AC upon ABC, which is 5/13. Correct? Then cos theta. Cos theta is adjacent upon hypotenuse, which is AB upon BC, which is equal to 12/13. Tan theta is opposite upon, yes, adjacent, right? Which is equal to AC upon AB, which is 5/12, right? Now, just the reciprocal of sine is cosec. So just put the inverse of this, 13/5. Sec theta, it's hypotenuse upon adjacent, just the opposite of it, 13/12. So hypotenuse upon adjacent. And cot theta. Cot theta is just opposite of tan, which is 12/5. So if you look into the figure, this is hypotenuse upon opposite, this is hypotenuse upon adjacent, and this is adjacent upon opposite. Now the thing is, I've taken the angle as theta, and they are saying angle B. So if you are going to write theta, then label B as theta in the figure. Okay, or you can take capital B. So sin B, cos B, tan B, cosec B, sec B, cot B. Again, a quick revision. Sin theta is opposite upon hypotenuse. Cos theta is adjacent upon hypotenuse. Tan theta is sin theta upon cos theta, which is opposite upon adjacent, O upon A. Cosec theta is inverse, so it's hypotenuse upon opposite. Sec theta is hypotenuse upon adjacent. Cot theta is adjacent upon opposite. These ratios are common for both the acute angle. The adjacent and the opposite shifts based on the acute angle that we are selecting. Hope this is clear, right? Let's take a different type of equation. Again, they are saying triangle ABC. Right angled is A. So let's say A here, B here, and C here. They are saying AB is 5. Oh, that I should put B here above. Okay. B here and C here. Okay. AB is 5. AC is 12. BC is 13. They are telling us to find sin B, cos C, and tan B. Right? So first I am taking B. For B, this is my opposite. This is my adjacent. And this is hypotenuse. Right? So first I'll write the sine. So sine B will be opposite upon hypotenuse, which is 12/13, and tan B. So tan B is opposite upon adjacent, which is 12/5. Now for angle C, the opposite is this one and adjacent is this one. So cos C will be equal to adjacent upon hypotenuse, which is 12/13. Hope this is clear. Thank you.